Greetings once again. Welcome to yet another title within the canon of universal literature. I've been rather excited recently about all these titles, but this one, I don't even know where to begin the excitement. It may seem a bit prosaic, boring from the title. Treatise on Conic Sections. What is that? Well, it happens to be the book that changed the world. Yet it's a book that hardly anybody knows about, except mathematicians and scientific historians, that is, those historians who specialize in the history of science and mathematics. The Treatise on Conic Sections, which was written around 225 BCE by Apollonius of Perga, and Perga is a geographic place name for an area in what is Asia Minor. See, the geometry of the straight line and the circle goes back to the ancient Egyptians, the Babylonians, and even earlier to the Akkadians, and quite possibly even the Sumerians. But only with the Greeks was it developed as a logically organized field of study, one of the 7 liberal arts. By the middle of the 5th century BCE, this development had reached the point where Hippocrates of Chios, now not the Hippocrates, the so-called father of medicine. Remember, many Greek names were as common then as they are now. That's why we say Hippocrates or Galen of so-and-so, so as to distinguish them from another person bearing the same name. This was Hippocrates of Chios, a mathematician in the grand style. He is said to have composed a book of elements on the circle and straight line. It was shortly after this that a new stage was initiated in mathematics through the introduction of the 3 famous classical problems. Number 1, the trisection of the angle. 2, the squaring of the circle. And 3, the duplication of the cube. The original intention was that these problems were to be solved by the use only of circles and straight lines. But failing to solve them in this way, Greek geometers looked about for other curves to use in the solution. It was not long before the first new curve, known as a Trisectrix or quadratrix, was discovered and applied in the solution of the first 2 problems. The duplication problem at first resisted all efforts to solve it. But in the following century, Manuscript, tutor of Alexander the Great, discovered curves which sufficed to solve the 3rd problem, that is, the duplication of the cube. These were the conic sections, the parabola, ellipse, and hyperbola, a family of curves which has played an essential role in mathematics and science ever since. What Manuscript, the tutor to Alexander the Great, wrote on the conics, unfortunately, has been lost, as has also the treatise on the same curves written a little later by Euclid, author of the famous Elements. However, there is extant, or still in existence, almost in its entirety, the work which marks the culmination of the Greek study of these curves, the Treatise on Conic Sections of Apollonius of Perga. Of the 8 books in this treatise, only the first 4 have survived in Greek. The next 3 have been preserved in Arabic translation, and the last, unfortunately, is lost. The subject of conics is taken up from the very elements, but the treatment advances rapidly, and roughly the last half of the work is on original results contributed by the author. Apollonius is responsible for obtaining all 3 types of conics from a single oblique circular cone of 2 naps, or napes, however you wish to pronounce it. And it was he who introduced the names ever since used for the three curves: parabola, ellipse, and hyperbola, or hyperbola. It's pronounced both ways. So far did Apollonius of Perga carry the development of the subject of conics that some of his theorems are equivalent to the theory of evolutes. There are about a dozen mathematical works ascribed to Apollonius, but apart from his conics, only one, on the cutting off of a ratio, is still in existence, and through the Arabic. Remember, it was Arabic scholars who, having basically been left with access to the famed yet all but destroyed Library of Alexandria, who were able to save many of the Greek works, classics, which have been preserved. We have 8th and 9th and 10th century Arab philosophers and scholars to thank for this. In fact, getting off the subject a bit, but our texts from many classical authors were translated from the Greek into the Arabic and then into Latin. And only until the advent of modern archaeology around the 19th century were we able to find the precious autographs, or at least the copies of a copy of an autograph of the original manuscripts. But getting back to the mathematics, so far we've covered the treatise on the conic sections and the problems it sought to resolve, and the impact it would have on both ancient and medieval culture. Now, getting back to this cutting off of a ratio, in the case of the others, only fragments, brief descriptions, or mere titles come down to us. Nevertheless, so admirable is his treatise on conic sections that this has been sufficient to earn for him, rather than for Euclid, the title, the great geometer of antiquity. Getting back to my original assertion, how is it that this book helped change the world? Those of you who are up on the basics of history of science will at once recognize one of these curves, the ellipse. Remember Johannes Kepler, the great student to Tycho Brahe, the Danish astronomer. Kepler had worked through much of his adult life on the orbits of the planets. Even their great mentor, Copernicus of Krakow, Copernicus, who gave us the heliocentric view of the universe as opposed to the earlier Ptolemaic one, was wrong in that he still clung on, he held on to the ancient belief that the planets moved in perfect circles. The mathematical equations of Kepler's great mentor, Tycho Brahe, did not work out using circles. One day it dawned on Kepler, and we're talking the 16th century here, more than 1700 years after the treatise on the conic sections, that it dawned on Kepler, why not try the ellipse? It worked. The orbits of the planets that had been based on meticulous and even excruciating observations seemed to mesh when Kepler used the ellipse. And the ellipse would not have been possible had it not been, for about 17 centuries earlier, the treatise on the conic sections. So in a sense, this otherwise obscure Apollonius of Perga set off a chain of events that would culminate in the interplanetary probes that were sent in 1961 and 62, Pioneer 1, Pioneer 2, which of course would graduate into later generations of Voyager 1, Voyager 2. Every scientist, every contract scientist in NASA knew that the planets were in an elliptical orbit. Once again, thank you for joining us. We, in our Universal Canon of Literature series, I look forward to sharing with you the next title in the series. Have a pleasant weekend.